welcome. So, today is the last day of this course. So, today I will be talking about one very important aspect dealing with laser is the laser safety. Laser has a lot of advantages, but there may be a lot of you know uh, possibilities of accidents while using laser. So, one needs to be really uh, well aware of the sources of hazards that are possible when one uses lasers. Okay. So, in order to know that, we need to know what are the different classes of lasers. So, depending on their damaging power, the lasers are classified under several categories. For example, class 1 to class 4. So, let us have a look at those different classes. So, the class 1 laser is normally a safe thing, and one does not need to care much about any possible damage with class 1 laser. Class 1M laser also is generally safe, but some precaution one should take about that one. Class 2 laser, it deals with visible light at low power. It and when we talk about the danger of uh, having damage from laser is essentially the danger of damaging your eyes. Okay. So, for class 2 lasers, if you keep blinking, then the risk of any eye damage is very low. For class 2M laser, it uses UV or infrared light at low power. It is also generally safe, and some precaution you may require. Now, when you come to class 3 level lasers like class 3R or class 3A, it is safe for viewing with unaided eye, that is not by a telescope or something like that, then it can be really dangerous. While class 3B, viewing beam hazardous, and if you have like any surface where the laser light is falling, and it can reflect to you, it can be really dangerous. So, for that you make sure that wherever the laser light is falling, it must have a diffuse reflectance, so that you do not harm your eyes. Class 4 laser is extremely hazardous under all conditions, be it your eyes, be it your skin. Okay. So, one has to be extremely careful while you handling class 4 lasers. So, here again we show in this table what are the different areas where different classes of laser are used. So, class 1 laser, which are of low intensity, they are safe as we said, and they are typically used in CD writers or DVD writers, laser printers, etc. While class 2 also is moderately low, that is in the order of a milliwatt power and only in the visible color. One should not look into this class 2 lasers. For example, like these lasers are used in supermarket laser scanner, and in some pointers that are used for seminar presentations, and you should not look into this laser sources that can be damaging your eyes. Okay. And you better use a suitable goggles to protect your eyes. And you remember, whenever you use safety goggles for laser applications, it depends on the laser. So, for different class of laser, different color of laser, your safety goggles are different. So, just having a goggles is not good enough, but knowing that which goggles do you want for the particular laser is very much needed. Class 3A laser is very often used in laser pointers, and you should be careful about these laser pointers also. Class 3B lasers, it is dangerous. It is used in like many confocal microscopes, and basically like argon laser is a class 3 laser, and you should never look at the beam even in the reflection. And class 4 laser, as I said, they are of high power, and they if you expose that, I mean if you expose your skin or if you look at the beam, it's extremely dangerous. You can lose your eyesight totally, and you can damage your skin really in a bad way. So like all these industrial lasers, they are of mostly class 4 lasers, like what you use for laser ablations and all. Now wherever you have your laser in any room, you must you know put certain labels that saying that okay, this is the room where you have this class of laser. So you need, people will know that okay, what are the kinds of precautions that one needs to take. So for class 2 and class 3A laser, you use this you use the first type of label, while for class 3A, 3B and but when we talk about class 3A, you can have either expanded beam or very focused beam. So for expanded beam, this is sufficient, but for small beam class 3A laser or class 3B and class 4, you need to use this sign which clearly says that this is dangerous. Okay, the other one says it's a caution. Okay, so there is a clear difference between these two signs, one having the note caution, another having a note danger. So what are the safety measures that you need to take? Eyewear for all this class 3B, class 4 lasers for everyone in the laser room, and if you have beams going at a high distance, like and also having a larger power like 200 milliwatt, you must ensure that the beam goes through a tube, so that even by accident no one gets into the beam path and get himself or herself damaged. And the highest risk of having any accident from laser happens when one aligns the laser beam, or aligns the laser light through different optics outside. So that times the most precaution should be taken, most care should be taken, and while doing this alignment, is advisable that you use the minimum power that you can use. Okay, and these are some examples of different types of laser. You can see that there are different types of laser. So this is for visible laser, this is for infrared laser, and these lasers should be kept in safe condition. You should not damage the laser goggles, then it will not function as it is supposed to be. Okay, and there are goggles available which you can wear even if you are wearing specs, and there are certain isolators are also available which you can use as a divider to separate out several sections of the room where say multiple lasers are being used, which will block any kind of laser beam falling on them. Whenever you are using laser, and once the beam passes your say area of interest, say for example if you are doing spectroscopy, then the sample cell, once the laser passes through the sample cell, after that you make sure that the beam is dumped. Okay, otherwise the beam will go unattended and someone can meet with accident. And as I showed in the previous slide, that you use some reflective screens, which are kind of diffuse reflective screens to avoid any kind of accident. And you should not keep any unnecessary object near the laser, because any moment if you need something from that particular part, you may meet accident. Whenever you are aligning your laser beam, make sure that you are not aligning it to so high that it comes to your eye level. Okay, even now if it is almost inevitable to do that, then you make sure that the laser beam there goes through tubes. And a very important thing is that if you are working in a laser laboratory, you should know everything about laser safety and laser operation. One more important thing is that whenever you are working, make sure there is another person in a nearby place. In case anything happens, should be taken the second person can take care. And not to be mentioned, no one should put your body parts within laser beam path. Okay, you are going to damage yourself very badly. So there are several causes of accident from laser. Sometimes people do not wear eye protection, or sometimes the optics that are on the table, they are not properly aligned, so the misaligned beam takes the beam in a way direction where it is not supposed to go, and someone can meet the accident. Sometimes the equipment breaks down and then it misfires. The laser comes with cover, so if the cover is not in place, then the radiation can come out and you can have accident. Without informing someone else, if someone incorporates an extra optics in the beam path which reflects the beam in a different direction, that can cause accident. There are certain other features that one should know about. That is, one should not put reflecting objects inside beam path. Also, bypassing interlock can cause serious damage. Okay, so every laser comes with an interlock which is for safety, so anything happens electrically, so no further damage will take place. Interlock takes care about that one, but if you bypass the interlock, then you are at risk. And one should take a very proper care while turning on the power supply. Um, and before entering the laser lab, one must have a proper training of using the laser, about the laser safety. Without that, you may actually meet accident. Here are some figures where it shows like how lasers can badly damage you. So here are the images of burning injuries from carbon dioxide laser. You can see that this burning is quite severe. Okay, and these are the corneal injuries, that is in your eye, from carbon dioxide laser again. This on the right side, it is the retinal injury from a dye laser, and these injuries are quite irreversible, so one should be very careful of. So with this we will pretty much conclude this course, and before stopping, I would like to very briefly recollect what are the things that we have looked at in the last 8 weeks. So we started with the importance of laser, what are the places actually laser finds application in fundamental science, in industry. Then we looked into the basics of or fundamentals of the laser operation. So we talked about the optical transitions, the requirement of population inversion, and then the particular materials that can provide the states that can cause population inversion. So how many states are required for having population inversion as minimum. We looked into different levels of laser system. Then we looked into specific systems that can act as lasers. So we talked about solid state lasers, gas lasers, we talked about tunable lasers like dye lasers, we talked about different types of like continuous wave laser or pulse laser. Within the pulse laser, we talked about various different pulsing techniques like cavity dumping, Q switching, and active and passive Q switching, mode locking, active mode locking, passive mode locking. After learning about all those things, we started looking at the application side. So there we talked about nonlinear optics. We dealt with one particularly second order nonlinear optics and second harmonic generation in specific, with a little bit detail, and we also looked into the applications of lasers in spectroscopy, and as a whole the application of laser spectroscopy in various different other fields. For example, like in analytical science, where we showed how using ultra high resolution spectroscopy can help us in separating different isotopes. We also looked into the application of ultra short pulses laser in understanding the ultra fast chemical reactions and dynamics. We also looked into the application of lasers in chemistry. We looked into the laser induced chemistry. We also looked into the possibilities of using lasers in understanding a chemical reaction. We looked into the applications of lasers in biomedical fields. We tried to look into as many different fields as possible within medical sciences. We also looked into the applications of lasers in material science and engineering and optical communication, and most importantly at the end we talked about the topic of laser safety, which is very essential. So I hope I could convince you about the need of lasers in day-to-day life, and I could also tell you about its fundamental as well as applications. I hope that this knowledge, though it is very basic in nature, fundamental in nature, will be very helpful for you, and many of you will probably go through in much more depth afterwards, after having this course about lasers and laser applications. So I wish you all the best in your future. Thank you very much for attending this course.